In this video, I'm going to be walking you guys through a high-level overview on how you can secure your application end-to-end from a developer's laptop to a production environment like Kubernetes. So let's jump straight into it. Now, first of all, we'll talk about security of DevSecOps when relating to the software development lifecycle. We need to understand that in as much as we have a DevSecOps engineer or a DevOps engineer, when it comes to security, it is a shared responsibility. Now, everything does not just lies on the shoulder of the DevOps or the DevSecOps engineer. Everybody, every relevant stakeholder that is involved in this entire software development lifecycle have their own role to play. For instance, the DevOps engineer might be ensuring that the pipelines are running smoothly, the clusters are well secured and all of those things. But if the developer in question writing the application is not, writing the application in such a way that, the application is not vulnerable, it's just a matter of time before your application gets compromised. And most times, your infrastructure even gets compromised because of the application. All that in the later stage of this video. So let's start with a basic example, right? We have a developer writing the application code, right? They write the application code on your local machine, and then push to a central repository. Now you need to understand that at that point, so many things might go wrong, right? Let's say, for instance, the application, the developer write their code, they have their Docker file by their side. Obviously, you write your code, you package the code into a Docker image, you push to repository, and you deploy into a Kubernetes cluster or whatever environment you are running your application on. Now, this is what happened, right? The first thing, right, that happens that a developer or that a DevOps engineer is in charge of is the Docker file, right? The Docker file is such an important file for, the DevOps or the DevSecOps engineer, because in the Docker file, this is the blueprint where your application is going to be deployed off from, right? So your Docker file must be well scrutinized, right? You need to ensure that your Docker file are well structured in terms of, not running the application as a root user, which is very important because, as you all know, a root user in a container can be a root user in the host, because all containers in the host share the same kernel. So a root user, container, root user in the host. So be very careful about that. And secondly, there should be hard-coded secret inside your Docker container or your Docker file. Now, some people might write a step in a Docker file whereby they, impute a secret, and then at the later stage they delete it. Maybe they delete the secret, thinking that that's going to remove the entire secret from the Docker file, but it doesn't work like that. The way Docker file works is that each stage is a layer. So even if you remove your password or your credentials or your API tokens in a later stage in the pipeline, that particular code or that particular API key has already been cached on the previous layer where you've used it. So the fact that you remove it on a later stage does not necessarily mean that that cannot be found. If you scan that container extensively, you will go to reveal the secret. So the best practice, don't even use it. Now, if you need to use a secret, right, it's better you pass it at a runtime using secret and config maps in Kubernetes. Or if you need that secret in a build time, then you can use Axe, which just is used to build the application without actually embedding the secret inside the container itself. So now the question is that, do we actually have control over this on a developer's machine? That is a very vital question. Now, most times your developer can be scattered around all over the world. It can be the US, can be in the UK, can be in Germany, and you might not necessarily have control over that machine. So what do you do as a DevOps engineer? Now, as a DevOps engineer, this is where, or a DevSecOps engineer who is in charge, this is where you now need to play the role of a guard, whereby you set some certain guardrail that might prevent some certain security misconfiguration, right? For instance, on the dev machine, you can have a pre-commit hook that detects secrets, before even be pushed to the central repository, right? And also in some advanced organization, the devs can also have some tools in place in their IDE that helps them to prevent some of these issues like insecure coding practices, like SQL injections, code that are vulnerable to SQL injections, code that are not standard enough to validate or sanitize users input, and all of those things. So all of those needs to be embedded right in the dev's IDE, and it depends on the organization. So this is another point that is worth taking, right? And this brings about the concept of shift left security, whereby you are pushing security further left in the software development lifecycle, right? So that is that on the dev side. You scan your Docker image is in place, and and all of those. Now, after that, that particular repository needs to be pushed into a central repository where it needs to be merged to the master branch, build your container, and then push your registry. Now, this is where you have control over as a DevOps engineer, because this is like a central place where you have access to and you can actually monitor, right? Very important. Now, this is where you now need to start scannings, right? You need to scan your application or your repository. You can scan on a regular basis or based on commit. When somebody commits a new branch or a new commit to a repository, you need to have some stage in your pipeline where you need to scan those code extensively, and then based on the output, you can decide to promote it to the next stage, or you can fill the pipeline, and also send notification to your dev, right? Now, this is where you now need to impute some scannings like secret detection again to redetect. Sometimes a secret might slip through the pre-commit hook and gets maybe lands into your repository. Security is in depth, right? It's not just one layer, so you need to secure different layers of the stack as it moves from one stage to another, or from one point to another across the software development lifecycle. So you need to scan the application again, scan the code for secret, number one. You need to scan your open source libraries. Obviously, a huge chunk of your application are from open source, which you have no control over. So you need to scan those open source extensively as well to see if there's any vulnerabilities, if there's any CVE, etc. So you need to scan them, and then based on your results and findings, you can decide to remediate them on the fly, or you can tell the developers to fix those libraries, maybe upgrade the version, or even dish out those those vulnerabilities, those vulnerable open source libraries, and then use new ones. So it depends on your use case. And also, you also need to scan maybe SAST. Obviously, this has been done before, but this, like I said earlier, you need to secure every part of the way, so that even if a particular vulnerability slips through to the next stage, we can also cache it there and also fix it at that point. So after that, you scan all of these, once everything is fine, you can push to your Docker registry, where you can also need to scan them again. You need to scan your containers, etc. Because when it comes to CVE, a container might be 0% vulnerable, but in the next day, a new CVE might be discovered, and if you're not scanning your application code, you might just miss out on that new vulnerabilities, and then you are open for an attack. So you need to be scanning them, you need to be scanning them concurrently, repeatedly on your repository wherever your container lives in, right? And also, this is another important part, right? The ability for you to factor in how to add all these scans to your pipeline is a very complicated one, because when you have too many scans on your pipeline, it's makes the pipeline to be very complicated, and devs, your developers might not be happy, because they want to be able to see their code, they want to see their code live as quickly as possible. So when you are adding too many scans, you are delaying these, and your devs might not be happy. So you need to understand how you can run all these scans without actually causing a bottleneck to your devs, right? This is where you might need to run them in parallel, or run them in some certain branch. Obviously, not all commit needs to be scanned, right? For instance, if you are making changes to a README file, there's no point for you to scan the entire application, right? So that is another topic on for another day, but let's keep that. Now, once your application is in your ECR or whatever registry you are putting your application, that application needs to be deployed to a Kubernetes environment, right? This is another phase, right? Now you're now moving it into the infrastructures that run your application. This is very important because any compromise on this other side will not only compromise the application itself, but it's also going to compromise the infrastructure. Now, you need to understand the blast radius of a compromised container. So the first thing that you need to do on this side, you need to secure your Kubernetes cluster gateway. Now, this is where you need to be very careful with your RBAC. How are you deploying from your Git repository to your Kubernetes cluster? Are you using GitOps? Are you using kubectl directly from your CI/CD pipeline? Are you using an agent, or a runner on your or a runner of your repository running in Kubernetes? So all of these comes with a lot of trade-off, right? Which you need to understand, which I'm not going to dive into. But let's assume that your application is now deployed or it's now about to be deployed to a Kubernetes cluster. Now, the first thing that you might need to do is to secure the gateway, which is the gateway. This is where you can set some admission control, whereby you can specify that a particular application, right, a particular image is not authorized to be deployed to your cluster. Number one. Number two, image signing, right? Before even uploading your image to a repository, that image needs to be scanned extensively and also signed, sign your image. Now, this is a supply chain security measure whereby you want to be sure that whatever you have on whatever you built, right, and uploaded to your registry is exactly what you are having or exactly what you are deploying to your cluster. So this is very important. So you can verify that on the admission control as well. You need to verify it extensively and to ensure that this is exactly what you have and this is exactly what you are deploying, because in between, right, deployment, some images might be compromised and then you end up pulling a vulnerable image into your cluster. So ensuring that. And also, Kubernetes has some certain primitive, right, that can help you to secure your workload, to lock them down, and to ensure that the blast radius is reduced. Now, this is where you now need to start using what's it called, security context, right? Like not running your application as root user. Sometimes the root users might be enforced in your application, the Docker file, but when it gets to Kubernetes, this is where you cannot enforce that no container is allowed to run as a root. You can also drop some capabilities as well in that security context. You can also add some, some permissions, read-only file system, and all of those things can be set with the Q security context. And aside that, you also need to enforce some other stuff, right? You need to add some readiness probes, liveness probes to your Kubernetes manifest to ensure that your application is running and Kubernetes is able to detect when your application is not running. Now, this is not on the security side, but it's just a best practice, right? And also resource limit and request. Now, you might think that this might not be a security measure, but it does, right? There are some attacks that kind of, overwhelm your pod. And then if you don't have resource limit in place, your pod can just be using, resources which can, affect other pods running in that cluster, whereby they can be evicted or even starve them of resources, right? We have an attack whereby on Envoy, where Envoy is a target, and then with just a few minutes, that Envoy pod itself can be overwhelmed with flood of requests and then consuming the resources of the node, which can be disastrous, especially when you have critical application running on that node. So setting up your resource limit and request is very important as well. And also, another important part is your service account token. Now, by default, any pod comes with the default service account, right? So that default service account, right, if it is compromised, anybody that have access to that pod or to that container indirectly have access to the Kubernetes API. And once that happens, your entire cluster is compromised. Now, let's say, for example, right, you did not create a separate service account token for your application and are using a default service account. And let's say that the default service account have an admin privilege to the cluster, right? It means that all your application, all in that cluster that has that service account has been compromised entirely, right? Anybody that have exec access into those containers can actually communicate with your Kubernetes API, or even any process that can be hijacked inside that container have access to the Kubernetes API. So when creating an application, right, there are two things you need to do. It's either you don't mount a service account token inside a pod, or the default service account should never be used, right? You can enforce this at the admission controller level so that the default service account should not be used by any container. If any container wants to, or if any pod wants to use service account token, that should be created specifically for that pod, right? Nothing less. So after that, you have the application running, right? This is where you now need to expose your application, right? Exposing your application is another different thing, right? Obviously, you don't want to expose your application, right, without encryption, right? This is where you need to use HTTPS. And also, you also need to secure your communication between your pods in the cluster, right? By default, Kubernetes allows all pods to communicate with each other, which is not a security best practice, right? You should be able to restrict access to pods communication. We call this east-west traffic within your cluster. So you can use stuff like Mushra TLS for communication, encrypted communication, especially when you are running in a regulated environment like financial institute and all of those. So you need to regulate that. It's very important. Or you can use network policy, to isolate the networks from non-communication. For example, if you have the database pod running on your application, you don't want any pod talking to that database, right? You can use security policies to envelope it so that only the right pods or the alert pod are allowed to talk to that pod. So that is also an important consideration. These are some of the major security practices that you can implement that can boost your security posture, right? We have more of them, but these are the major ones, and this is just like a high-level overview. We can decide to zoom in into each aspect and go deeper, but this is just the overall view of how you can secure your application end to end. Now, if you like this kind of video, please follow, hit the like and subscribe button. Thank you so much for sticking around, and I will see you in the next video. Thank you so much. Bye.